The appearance of an outdoor scene changes dramatically over time. Season, time of day, weather all affect its visual appearance in some way. We study these variations and introduce transient attributes, which are high-level properties that describe the scene at a particular time. We define a list of 40 transient attributes related to lighting, such as sunrise or dusk, weather, such as clouds or sunny, season, such as winter. We also use a few subjective properties such as gloomy. In order to relate these properties with outdoor appearance, we annotate a large webcam database and describe each image with our transient attributes. Thanks to our database, we learn how to recognize transient attributes in new scenes, which is useful for exploring internet photo collections. Finally, we present a high-level image editing method which leverages the appearance variations in our dataset in order to modify scene properties of a new image. We download images captured by outdoor webcams over several months. For each webcam, we select some images that show large appearance variations. We use crowdsourcing to indicate whether each attribute is present in every image of our dataset. We combine annotations from multiple workers to obtain reliable attribute labels. In total, we annotate over 8,000 images from 101 scenes. Now that we have all of this data, how can we visualize it? Each image in our dataset corresponds to a point on a 40-dimensional attribute space spanned by our transient attributes. Shown here is that attribute space for 7 webcams. We visualize it in 2 dimensions after applying PCA. We can colorize this plot according to the labels for one attribute, such as sunny. Red dots correspond to images with a high value for the sunny attribute, such as this image, and the blue dots represent images with lower attribute values, like this one. We can select another attribute for the color coding, such as winter, or even a more subjective one, such as gloomy. Using our transient attribute dataset, we train regressors to recognize image attributes in new images. We leverage this to develop new user interfaces for searching images and exploring photo collections. In this example, we first search for images that are not taken at night. Then we refine the search to find autumn pictures. Finally, we filter out images with clouds. We can also browse a photo collection by retrieving images with more or less of a certain attribute. We decrease attribute winter. This corresponds to walking in a specific direction of the attribute space, as illustrated on the left. Then we retrieve an image with more clouds. Finally, we look for a sunset or sunrise image. Our most ambitious goal is to provide a simple user interface to edit an image based on transient attributes. In this example, the user specifies the desired attribute change, such as more rain. We leverage our dataset to find the proper appearance transformations to modify the input image. Our system automatically finds target images that depict a scene similar to the input and have the desired attributes. It is difficult to know what the user has in mind when she asks for more rain. Using the interactive mode, she selects a target image that corresponds to the specific appearance change she wants. Our system edits the image by transferring local color transforms as described in the paper. The result is obtained in just a few seconds. In this example, the user specifies a different attribute change, more dry. This time, in automatic mode, the user sees the appearance transfer results for all target images selected by our method. We now show some more examples of appearance transfer obtained with our approach. All of these images result entirely from image manipulation. Even though they look plausible, they are not real photographs. Our transient attribute database and our regressors are publicly available on our website.